KCET 2025 aspirants. So I hope all of you are preparing really hard for your KCET examination, and in today's video we are going to do top 30 MCQs from one of the very high weightage topic, that is solutions. Okay, so from this chapter you can easily expect 4 to 5 questions. So and the questions can be also on the tougher side because this is a very high weightage topic. So I have brought you a mix of all the types of questions from this chapter. Okay, so let's get started with the first question here, that is very simple from your concentration term. Molarity of a 10% W by W Na2CO3 aqueous solution is. Okay, so now molarity you want to calculate. W by W means 10%. Given mass is W is 10 gram. Okay, means mass of the solute is 10 gram and mass of the solution is 100 gram. Okay, and we know that it is an aqueous solution, so density of water is 1 gram per ml. So I can say that volume of water will be this into 1 gram per ml. Okay, so one second, molarity of 10% W by W, right? Yes, so I will get volume is equal to 1 ml, 100 ml. Let us see the first question here. The molarity of 10% W by W Na2CO3 aqueous solution is. Now if you see here 10% W by W, I can say that means mass of the solute. Mass of solute, or your solute is nothing but Na2CO3. Okay, so now if I see mass of the solute is 10 grams. Okay, and what is the mass of the solution? Mass of solution is equal to 100 grams, right? And it is an aqueous solution, so I can say that density of the solution or density of this one will be 1 gram per ml. Okay, so now if I see, we have density is equal to mass by volume. So what is volume? Volume is equal to mass by density. So I can have the volume of water or volume of the solution, okay, will be 100 gram by 1 gram per ml. I can say 100 ml. Okay, now what is the molar mass of Na2CO3? So 23 into 2, 46, 46 plus 12 plus 48. So 8 plus 2, 10, 16, I think it will be 106 gram per mole. Okay, so now we have got all the values. Simply we can calculate the molarity, right? So what is the formula for molarity? So molarity is equal to given mass by molar mass into 1000, right, by volume of the solution. Okay, so I am writing the formula so you can revise it. So what is the given mass? 10 gram, 10% 10 gram. What is the molar mass? 106 into 1000 by 100. Okay, so if I see, it will be 100 by 106, right? So this will be very near to 0.9 and that will be equal to 1 point something. So option number D here. Okay, next, a liter of sea water whose density is given to you contains 5 into 10 to the power of minus 3 gram of dissolved oxygen. Its concentration in ppm is. Okay, so if I want to calculate the concentration in ppm, okay, the formula is mass of the solute by mass of the solution, right, into 10 to the power of 6. Right, this is the formula. Now how can I write here? Now you see the solute is 5 into 10 to the power of minus 3 grams. Now 1 liter means what? 1000 ml. Okay, now density is 1.04 gram per ml. So I can say what is the mass of the solution. Again, density is equal to mass by volume. So mass will be equal to density into volume. Density is 1.04, right, into 1 liter, that is 1000 ml, 10 to the power of 3, 1040. Okay, so I will get here 5 into 10 to the power of minus 3, right, 5 into 10 to the power of minus 3 divided by 1040 into 10 to the power of 6, right. So now what I will do is, for easy calculation, you can think this is 6 minus 3000, right. So I have 5000, okay, and divided by 1040. Okay, so we can divide it quickly. 5000 divided by 1040. Okay, so if you take exactly 1000, the answer will be 5, right? But it is slightly more than 1000, so it answers should be slightly less than 5, right? So that is why I can easily see answer which is slightly less than 5 is 4.8. I hope you are getting this one, not doing the calculation. 5000 by 1000, right? So that is equal to 5. If this denominator is increasing, the value will decrease. Something less than 5, only one option, option number C. Next, which one of the following equilibrium exists in a saturated solution of solid and liquid? So in a saturated solution, there is an equilibrium between solute and solution. Okay, so solid, solute and solution, right? Solute is solid and solution is liquid, so option number C. You should not be doubtful here whether it is solvent or solution. In an equilibrium, it is the equilibrium between the solute and the solution. Okay. Next, the mole fraction of water which CO2 is dissolved is 0.97. If its partial pressure is 2 bar, then the Henry's law constant is. Okay. Okay. Now this is very tricky question, but easy question as well. You see, the mole fraction of water in which CO2 is dissolved is 0.97. So I have mole fraction of water 0.97. What is the mole fractions of CO2 then? I can just subtract this one, 0.03. You have to find the partial pressure is 2 bar and the Henry's law constant I have to find. So if I know Henry's law formula, P of the gas is equal to KH into mole fraction of the gas, right? So mole fraction of the gas, this is 2 bar, pressure is 2 bar, divided by 0.03 is equal to KH value. So I can write 200 divided by 3. So I will get 66 point something, 66.66 bar. So that is option number B. Easy calculation question. Next, a gas X is dissolved in water at 2 bar pressure. Okay, if the mole fraction is 0.02 in the solution, the mole fraction of water when the pressure of the gas is doubled at the same temperature. So the question is very simple here. If the pressure is 2 bar, then the mole fraction that is dissolved in the solution is 0.02. If you increase the pressure to double, then what is the mole fraction? The mole fraction of the water. Question is very tricky. Mole fraction of the water when you increase the pressure to double. Okay, so see, we have this formula. So I can write P1 is equal to KH into X1, P2 is equal to KH into X2, right? Now initially the pressure was how much? So I can write down the relation P1 by P2 is equal to X1 by X2. P1 was 2 bar, now if I double it is 4. Right, and here it is 0.02, so I have to find X2. So if I solve this, you will get X2 is equal to 0.04, but that is what? This is the mole fraction of X. This is the mole fraction of X. But the question is asking me the mole fraction of water, mole fraction of water. So it will be what? 1 minus 0.04. So that is equal to 0.96, option number C here. Okay, I hope this is clear. Next, 2.5 gram of a non-volatile solute is dissolved in 100 gram of water. If the vapor pressure of the water is 100 mm of Hg at that temperature, the vapor pressure of the solution is. Okay, so first of all, this is normal question. Relative lowering of vapor pressure. So when we add any solute, the vapor pressure will decrease, right? So I have 100 minus the vapor pressure of the solution divided by 100, that is the vapor pressure of the pure solvent, is equal to XB, right? And XB is nothing but number of moles of solute by number of moles of solvent. So I have 2.5 divided by 94, okay, into, in this one when we use XB, it is NA by NB, right? It is not, sorry, NB by, here we do a small modification. Here we don't, or we ignore the number of moles of solute. Why? Because compared to solvent, the solute molecules are very less. So NB by NA. So this is NB. NA is how much? 100 gram of water, right? So 100 divided by 18. So now for some easy calculation, what I will do is, okay, let me try to solve it in some easy way. I will make this one as 90. Okay, so let me just do rough calculation here, 2.5. So how I should have done this in exam? Into 18 by 100, right? So 2.5 I have 18 5s are, okay, then 5 I have 0.5, right? And then this side I have, so I can write it as 0.005, right? And this side I have 100 minus 0. So if I take this one, 100 minus 100 minus p, 0.005, that will be somewhere around 99 point something, right? So I know 99 point something, I have only one option, so option number C here, okay? Next, at 298 Kelvin, the vapor pressure of pure liquid X is 120 mm of Hg and the vapor pressure of pure liquid Y is 100 mm of Hg. Molar masses of both are given. If 10 gram each of these liquids are mixed, the vapor pressure of the resultant solution will be. This is very easy question, but calculation may take some time. So I have what? First I have X, okay? Its pressure is 120, 10 gram is taken, molar mass is how much? 100 grams. For Y, pressure is how much? 100 mm of Hg, 10 gram is taken and 80 gram per mole is the molar mass. Okay. Okay, next what happens? We have to calculate the total vapor pressure, right? So I can do one thing. First, number of moles of X is how much? 10 by 100. Okay. Number of moles of Y is 10 by 80. So what I will do is I will calculate the total number of moles, right? So 10 by 100 plus 10 by 80. Okay. So if I see the LCM I can take is 400, right? So 40 plus here it is 50, so it is 90 by 400, right? So now if I just put the formula for P total, it is P naught X, that is 120 into XA. So XA is what? NA by N total. So not NA, here it is, I will use the term that is X and Y, right? Then plus I have here 100 into NY by N total, right? So total I can write it like this, 120 into NX plus 100 into NY divided by N total. Okay, so now I will do some substitution. So let us see here. So I can write like this, 120 into 10 by 100, okay, plus 100 into 10 by 80, right? This is 10 by 80, okay. Then divided by 90 by 400, which I can write as 400 into 90. Okay. So now we have to do the calculation. I can solve it like this. This one cancel. This is 12. And this I cancel this one. Then it is 4 2s are 8, 12.5. Right. So 12.5 plus 12, that is 24.5. 24.5 into 400 by 90, right? I can cancel this one. So now if I just multiply with 4 5s are 20, 4 4s are 16, 17, 18, 4 5s are 20, 4 4s are 16, 17, 18, 4 2s are 8, plus 1 9, then I have one more 0 here and I will put 1 decimal. So 980 divided by 9, right? So I can say 9 1s are 9, then I have 9 0, so 1 0 will come, 100 will definitely not come, 108 is there, then option number C here. Okay. Let us see the next question here. An aqueous solution contains 6% and 4% by mass of molecular weight is given. So you have to find the molarities individually. Okay. So let us first take for molarity of X will be what? Given mass, that is 4, by molar mass is how much? 120, right? Into 1000 by 100. Okay. So I can cancel this one. I will get 1 by 3, right? Yes. Next, molarity of Y here. So I have here 4, that is 6, right? 6 by 180 into 1000 by 100. Again, I can cancel this one. So I will get 1 by 3, right? So for 4, the mass was 120. Oh, no. I did wrong here. Just a minute. See, I have taken wrong values. 6% of X is there, and its molar mass is how much? 120. So it is 6 by 120 into 1000 by 100, right? So I will get here 1 by 2, and I have 4% of Y, right, whose molecular weight is 180. So I have 4 by 180 into 1000, right, by 100. So I have 2 by 9 here. So 1 by 2 and 2 by 9 are the molarities that I have calculated. Now I can use this formula, delta TB is equal to, right, KB into M1 plus M2. Okay, so what is the value of KB here? 0.52. Okay, M1 value is, I have 1 by 2 and 2 by 9. So just for simple calculation, let us quickly take the LCM. Suppose 18 here. So 2 9s are 18 and 9 2s are 18. So it is like this. So I will get 0.52 into 13 by 18. Okay. So can we solve this? So I can say that 2 9s are 18, then 2.13. Sorry, 2 2s are 26. Right, so 0.26 I will get. So if I just do a rough calculation, if I take it as 0.27, right, this is 0.26 into 13 by 9. So if I do a rough calculation, take it as 0.27, then it is 0.03 into 13. So that is 13 3s are 0.39, or roughly I can say 0.4. Okay, now this side I have what? TB minus 100. Right, so if I take that one to this side, I'll get 100.4. So that is option number A. Okay, simple question, just you need to know M1 plus M2. Okay, next, 3% W by V aqueous solution of glucose is isotonic with 2% W by V aqueous solution of X solute. Now, if 6 gram of X is dissolved in 100 gram of water, the molarity of the solution is. Now, if I know whenever it is given isotonic, just remember C1 is equal to C2. Okay, molarity will be equal of both of them. 3% aqueous solution of glucose. So what is the, so this is glucose and this is X. C1 is what? If you remember, isotonic means what? Pi 1 is equal to pi 2. That means C1 RT is equal to C2 RT. This one get cancelled. So from there I get C1 is equal to C2. Now what I can do here, I have this C1, I can calculate 3%, W by V means 3 gram in 100 ml, right? So I can write 3 by 180, given mass by molar mass. Glucose mass is 180, right? So given mass by molar mass into 1000 by volume is 100, right? When it is percentage, volume is 100, is equal to 2%. So given mass by molar mass into same 1000 by 100. Okay, so this one will get cancelled. So what is M value here? M value is 2 into 180 divided by 3. 120 gram per mole. Okay, 180 by 2 into 3. So it is 120 gram per mole. We got the molar mass value. Now what we have to do? Just a minute. Okay. Now we want to calculate what? If 6 gram is dissolved in 100 gram, the molarity you have to calculate. So we have given mass is 6 gram, molar mass I have found out 120 into 1000, right, below 100 gram, dissolved in 100 gram of the solvent. Simple calculation, 1 by 2, that is 0.5. So option number C here. Okay. Next, the molecular mass of a solute determined by depression in the freezing point method was 90. Okay, if its actual molecular mass is 60, okay, and it undergoes dimerization, then the degree of association of the solution is. So if you remember, I value, okay, I value is what? Actual molar mass divided by the calculated molar mass. So I value is actual mass divided by the abnormal mass, right? Now what is actual mass? The actual mass was 60 and the molar mass calculated was 90. So it is 2 by 3. Okay. Now what we have to do? We have to calculate the degree of association. Now that is your alpha. Alpha is equal to I minus 1 divided by 1 by n minus 1. So what is I value? I have got 2 by 3 minus 1 whole divided by 1 by 2 minus 1. Now what is this one? 2 by 3 minus 1. So it is minus 1 by 3 and divided by minus 1 by 2. So if I take this one, I will get 2 by 3, which is 0.6 I think, or if you convert it into percentage, you will get 66%. That is option number C. Okay. Next, 1 molar glucose solution boils at 1000.54 degrees Celsius. Okay. RLVP, that is relative lowering of vapor pressure of the aqueous urea solution, is 0.018. The elevation in the boiling point of the urea solution is very, very important question. Now see, 1 molar glucose solution boils at this much degree Celsius. Now what is the point of giving this value? We have to find the value of Kb from here. Let's go from backward. What I have to calculate? The elevation of the boiling point of urea solution. So I need delta Tb is equal to Kb into m, right? So I don't have m value, I don't have Kb value for this particular question, right? Now before to that, what question is given? RLVP of aqueous urea solution is 0.018. So if you remember, RLVP delta P minus P naught is equal to XB, where urea, and this is given to me as 0.018. So I can say that the mole fraction of urea is 0.018. So from this mole fraction, I have to somehow find the molality, right? So now if you see, what we do here is, X of urea is what? X of urea means what? Number of moles of urea by number of moles of water, 0.018, right? Now number of moles of water is will be okay, so I have to find here number of moles of urea is equal to 0.018 into number of moles of water. Sorry, 1 second. Yes. Okay. Now here if you see, I can put it as we have taken 1 molar solution, right? You are taking 1 molar solution. So for 1 molar, what I can do means 1 kg of water is there. So 0.018 into given mass is, I will put 1000 gram divided by 18. Okay. So now if I solve this, it will be like 18 into 10 to the power of minus 3, right? 18 will cancel. So I will get number of moles of urea as 1. Okay, roughly I'll get number of moles of urea as 1. Now I have found number of moles of urea, then can I find molality now? So what is the molality of urea? Again, number of moles divided by 1000, that is given mass, by molar mass, right? Sorry, I'm assuming that it is a 1 kg solvent. Why? Because 1 molar is given here, right? So I will get molality as 1. Clear? Now let me calculate the Kb value. What is Kb value again? So Kb, if you know, I have this formula for Kb for a particular solvent remains same. So if I have glucose solution, then delta Tb is equal to Kb into m. So delta Tb is 100 minus 0.54, so that will be 54, and 1 molar, so Kb equal to 0.54, molality is equal to 1. So if I just substitute delta Tb value, Kb is 0.54, molality is equal to 1, I will get 0.54. So option number D here. Once again I want to explain this one. So first of all, from the first solution that is given, 1 molar glucose solution, if from this is the first step I will do. Okay, step number 1, delta Tb is equal to Kbm. So I am finding the Kb value of water here. The Kb and K value are always for the solvent, right? So you can easily calculate the Kb value for this one. Okay, now I have got the Kb value. Now RLVP of aqueous urea solution is given to you. RLVP means XB is given to you. From XB or X of urea is given to me. Now number of moles of urea, that is, I have ignored here number of moles of urea in the denominator because to make the calculation easy. So it can be often neglected. Number of moles of urea by number of moles of water is equal to 0.018. Now number of moles of urea will be what? Number of 0.018 into number of moles of water. Now here what I am doing, number of moles of water because we are assuming that it is a 1 molar solution or 1 kg of solvent is taken. So given mass by molar mass. So I will get number of moles of urea as 1. So if number of moles of molality will also be 1 because it is 1 kg solvent. So 1 mole in 1 kg, so that is 1 molal. Then you have to substitute here and we'll get option number D. Okay. Next, in a 0.2 molar aqueous solution of weak acid HX, the degree of ionization is given. Taking the K for water is this much, the freezing point of the solution will be nearest to. Okay. So we have been given with degree of ionization, right? So degree of ionization, if I want to find the value of Van 't Hoff factor, I minus 1 by n minus 1 for dissociation, right? So alpha value is how much? Alpha value is given to me as 0.3. 0.3 is equal to I minus 1 by n value. If H and X will dissociate, we'll get 2 ions, 2 minus 1, so that is 1. So I will get here I value as 1.3. Okay. So now you have to find the freezing point of the solution. So if you remember, T naught F, that is 0, minus Tf is equal to I into Kf into M, right? So this is 0 minus Tf is equal to I value is 1.3, okay. Kf value is how much? 1.85, okay, and molality is given 0.2, okay. Let us do some calculations here. 1.3, 1.85 also I am taking at 0.2, this one also I am taking at 0.2, so 2 2s are 4, right? So 4 into 1.3, so I can say means this decimal is there, 13 into 4, 52, right? So how many points I have? 1, 2, 3 decimal, 0.052, right? So you can see here, one second, 1.8, I assumed it as 2. Okay, so here there is no decimal, here I did a mistake. 1.8 is not 0.2, it is 2, right? This is, I am assuming is a 2. So 2.2 into 0.2 is 13, 1.3 into 4, 0.4. So I will get 0.52. So now you can see that this is 0 minus Tf. So Tf will be equal to minus 0.52, right? So you can see the nearest answer here, 0.52 nearest answer is minus 0.48, option number A. Next, during the depression in the freezing point of a solution, the following are in equilibrium. So we have solid solvent, right? Solid solvent and liquid solvent. Yes, option number A are in equilibrium. Next, two solutions of a substance, non-electrolyte, are mixed in the manner 480 ml of 1.5 molar first solution and 520 ml of 1.2 molar second solution. What is the final mixture? So whenever you are given these type of questions, so you should know that molarity is equal to number of moles by volume. So what is number of moles? Molarity into volume, right? So from the first solution, what is the number of moles? 480, okay, into 1000 is also there, right? So I can say m into v by 1000, right? This is the number of moles formula. So I can have n1 from the first solution. What is the number of moles? 480 into 1.5 into 10 to the power of minus 3. Now n2 is equal to how much? I have here 520 ml, okay, into 1.2 into 10 to the power of minus 3. So what is n total here? Okay, so let me just multiply this one. 15 zeros are 0, okay, 15 zeros are 0, 15 8s are 8 5s are 40, 8 120. So again 0 and carried here 12, 15 1s are 15, 15 plus 12, that is 27, okay. So I got, and I have to put, so 270 into 10 to the power of minus 3 I got. Here I will get what? I will just multiply 12 zeros are 0, 12 2s are 24, 2 carried, 12 5s are 60 plus 2, 62. Again I will have one decimal. So I have here n total 270 plus 624 into 10 to the power of minus 3, right? So 40789 678. 789, yes, 894 into 10 to the power of minus 3, okay. Now what I have, just a minute, number of moles we have calculated. Once again I'll do the calculation. 15 zeros are 0, 15 eights are 120, 0 I carried 12. Okay, here I did a mistake. 15 fours are 60, right? 60 plus 2, here it is 72. Yes, so here is a blunder, 72. So I will get 720 this one, right? 720. So if I add this one, I will get how much? 413. Okay, now this is the number of moles. Now what is molarity? Number of moles into 1000 by volume in ml, right? So n total I got 1344 into 10 to the power of minus 3, so 1.344 into 10 to the power of 3. Now what is the total volume? 480 plus 520, again it is also 1000, so it will get cancelled. 1.344, that is option number B. Okay, next, a 5.25 solution of a substance is isotonic with 1.5% solution of urea. Molar mass is given in the same solvent. If the density of both the solutions are assumed to be equal to 1 gram per centimeter cube, molar mass of the substance will be. So I told you already, when the isotonic solutions are given, simply you have to do, what you have to do is C1 is equal to C2. Okay, so what is there here? 5.25. okay, given mass by molar mass is how much for this one, that is what I have to calculate, right? Into 1000 by mass of the solution. So if it is 100 gram, mass of the, sorry, if it is in percentage, mass of the solution is 100 gram and here it is density is 1 gram per ml. So see, the mass of the solution is 100 gram, right? Density of the solution is 1 gram per ml. Then I can say that the volume of the solution will be what? Density by mass by density, so I will get 100 ml, right? So for both the cases the volume is 100. Similarly here what I can do, 1.5 by 60 into 1000 by 100. Okay, so this I will cancel. What is the value of x here? 5.25 into 60 divided by 1.5. So I can write this like this. I have removed the decimal and added a 0 here. So 15 fours are 60. So I got 4 fives are 20, 4 twos are 9, 10, 4 fives are 20 plus 1, 21, and here I have 0. And I have 2 decimals, so 210, option number C. Okay. Next, assertion reason. Aquatic species are less comfortable in cold water than in warm water? No. Aquatic animals are more comfortable in cold water. Why? Because when temperature is low, solubility of the gases will be more. So in cold water, more amount of oxygen is dissolved. So if more amount of oxygen will be dissolved, they will be more comfortable. So assertion is only not true. So that is why option number D. Okay. Next, this is very important question. It's a previous year question. A sample of water is found to contain 5.85% of AB, okay, and 9.5% of XY2. Assuming 80% ionization of AB and 60% ionization of XY2, the freezing point of water sample is, okay. So we have a very simple formula here. First of all, I have delta TF, okay, is equal to KF into I1 M1 plus I2 M2, right? In the previous question also you see we did M1 into M2. Now if they are having electrolytic solutes, then I1 M1 plus I2 M2. So first let us calculate one by one. So if I first calculate M1 and M2, so what is M1? Or I can just write down the name of the compounds here, not A1 and 2. So it is, what is the name of the compound? It is AB and XY2, right? So I have IAB and MAB, IXY2 and MXY2. Okay, so let me first calculate M of AB. So molality is what? Given mass. What is the given mass? 5.85, right? Divided by molar mass is 58.5 into 1000 by what is the mass of the solution? Sorry, mass of the this one 100 gram, right? Yes. So now what I can do here is I'll get molality as 1. Okay, you can just see, you can subtract 100 minus 5.85, but that will make the calculation little lengthy, so I'm just putting 100 here. So actually the mass of the solution is 95 point something you will get, but for easy calculation I'm taking 1 here. Okay, similarly for MXY2, it will be equal to how much? 9.5, right, divided by 95 into 100. Okay, again here also it will come 91 point something, but for rough calculation I'm taking it as 100, so I will get 1. So M1 and M2 I'll get little different value, but I have assumed both of them to be 1, so that my one part of the calculation will be easy. Now next part is I have to calculate I of AB. Okay, I is what? So if you remember, we have this formula, alpha is equal to I minus 1 by n minus 1. So what is the value of alpha for AB? You see, 80% ionization is there, right? 80% means 0.8. So I will write here 0.8 is equal to I minus 1 by 2. AB will give you 2 ions, so 2 minus 1, so I here is equal to 1.8. Next what I will do, I of XY2. Okay, so again here alpha value is how much? Alpha value is given to me as 60%, right? So 0.6 is equal to I minus 1. XY2 will give me total 3 ions, so 3 minus 1. So 2, I will get here 2. 2 into 0.6 is 1.2. 1.2 plus 1 is 2.2. 2.2 is equal to I. Here it is 1.8 and here it is 2.2. Done. Now let us solve the question here. Kf value is given to me as, where is Kf value? 1.86. Okay, IAB I calculated 1.8 plus 1 is there, I am just ignoring this, and I got here 2.2 into 1. Okay, so now, so if I just add them, 8 plus 2 10 and 2 3 4, so I'll get 4 here, right? 8 plus 2, yeah, 4 into 1.86, so that is 4 6 are 24, 4 8 are 32, 4 6 are 24, 4 8 are 32 plus 2 34, 3 7.44 I will get here, right? Now what is the TF value? TF is what? 0 minus sorry, yes, 1 second, I will get here 273 minus TF is equal to 7.44. So just take this one and this side, so I'll get 273 minus 7.44, so that is equal to 10 minus 4 6, 9 minus 4 5, right? Then 16 minus 7, so let me subtract it properly, 273 and I have 7.44. So 10 minus 4 6, 9 minus 4 5. Now I have already given here 1, so 12 is left. 12 minus 7 is 5. Okay, and I have 6 here and 265.56. Okay, so you can see the correct answer for this question will be option number D. Okay, now moving to next question. A mixture of phenol and aniline shows a negative deviation, and that is due to they form intermolecular hydrogen bonding, option number C. Next, how many grams of sucrose should be dissolved in 100 gram in order to produce a solution with 104.74 degree difference between the boiling point and the freezing point of the temperature of the freezing point temperature? This is a good question. Okay, so now you see we have a very we'll just write down the basic formula here. Delta TB is equal to what? KB into M, right? Delta TF is equal to KF into M. Now this I can expand and write down as like this: TB minus T naught B is equal to KB into M. And this one I can write down TF minus TF is equal to KF into M. Now let me add both the equations, right? So if I add both the equations, I will get the question is asking to find the difference between boiling point and freezing point, right? So I will get here TB, okay, minus TF. So I have taken these two together, then minus T naught B plus T naught F, okay, is equal to KB plus KF into M. Okay, so now you see this value I have to calculate. TB minus TF value I have to calculate. Now this is boiling point is 100 degree and freezing point is 0. So this one will come 100, right? Next KB plus KF 1.86 plus 5 1, 6 plus 1 7, 8 plus 5 13 and this is 1. So I will get 2.37. Okay. Next molarity. So how many grams of sucrose? So that I have to calculate W by 342 into 1000 divided by 100 gram of water. Okay, so here this is the part where I have to calculate this W. So I have now, if I just solve this right hand side part, 237, okay, by W into 342 by this is 10, right? So I can see anything, I can do the calculation here. 2.37 divided by 342. Okay, let me just do some arrangement here. So it is 23.7 I can say, right, if I multiply this 10 here. So 23.7 divided by 23.7 divided by 342 if I do. So how much I will get? Okay, 1 second. Okay, 23.7 divided by 342. So first it won't go, so I'll add the decimal here, then a 0 here, right? Then again a 0 I have to add. Sorry, just a minute. So now you see the question that is asked, that TB minus TF should be equal to how much? This one value should be 104.74, right? So produce a solution with 10.74 difference between this one. So here I have 104.74 minus 100. So that will be equal to what? 4.74. So let us do the next question. This is a little bit tricky question. So, sir, how many grams of sucrose should be dissolved in 100 gram of water in order to produce a solution with 104.74 degree difference between the boiling point and freezing point of the solution? So, if I know the formula delta TB, right, that is equal to KB into M, or I can write it in the expanded form, that is TB minus T naught B is equal to KB into M. Similarly, if I have delta TF, that is equal to KF into M, and I can expand it like this, T naught F minus TF is equal to KF into M. Now if I add these two equations, okay, so I have to find the difference between the boiling point and the freezing point. So TB minus TF I will write together, okay, then I have here minus T naught B plus T naught F is equal to KB plus KF into M, right? So now TB minus TF value is given to me how much? 104.74, right? 104.74. This is minus 100 degree and this is 0 degree is equal to KB plus KF. How much I will get? I'll just add this one, 6 plus 1 7, 8 plus 5 13, so 2.37. So 2.37 into M. Right now if you see this is 0, so I just left with 4.74 here is equal to 2.37 into M. So if you see this is just 2 times, right? 2 is equal to given mass by molar mass into 1000 by 100, right? So how can I solve this? W will be equal to 342 into 2, 342 into 2 by 10. So you can see 2 2s are 4, 2 4s are 8 and 2 3s are 6 divided by 10, 68.4. So option number B is the nearest answer. Okay. Next, this is a very easy question. See, FeCl3 on reaction with K4FeCN6 in aqueous solution gives a blue color. Now these two solutions are separated by a semi-permeable membrane XY as shown. Due to osmosis there is. Now see here the concentration, if you can't see I'll tell you, this is 0.2 and this is 0.02. Okay. So now what will happen? This is less concentrated, so water will flow from this side to this side, right? This side I have FeCl3 and this side I have FeCN6, right? But if you remember that in osmosis there is only the solvent molecules will participate, not the solute molecules. So water will flow from this side to this side, but there is no flow of FeCl3. So if there is no solute for going, then there will be no reaction, no color change, so no blue color formation will take place. Okay, next, some common salt is added to ice taken in a flask kept at 0 degrees Celsius with time. So what happens when you add some salt, the freezing point decreases, so the ice will melt, right? If the ice will melt, the mass of the ice will decrease. Next, a solution of sucrose has been prepared by dissolving 69.5 gram of sucrose in 1000 gram of water. The freezing point of the solution obtained will be. Very direct question from your colligative property. So first what we can do, we have here delta TF, which is equal to TF minus, which is equal to T naught F minus TF is equal to KF into M. So here what I have, T naught F I have to find out, right? Okay, solution water, right? So T naught F is very obvious, 0 minus TF, I have to calculate this one. KF value is 1.86. Okay, now M value, what is the given mass? 69.5, molar mass 342 into 1000, okay, divided by I have how much gram? 1000 gram of water only. So this part is cancelled. So I have 1.86 into 69.5 divided by 340. Okay, so what all we can do here? I can think this one as 70, okay, and this one as 2, 1.8 as 2, and 340. 340 is there, I'll make it 350. Okay, because this I can divide. So I can just cancel 7 ones are 7 fives are. So 2 by 5 will be 0. How much? 0.4, right? So TF value will be somewhere around minus 0.4. So I have this value minus 0.37. Correct answer is minus 0.372. Okay. Next, 200 ml of an aqueous solution of a protein contains 1.2 gram of a solute. The osmotic pressure is this much. The molar mass of the protein will be. Again, very direct formula from osmotic pressure. So we have this formula, pi is equal to C into R into T. So what is the concentration here? 1.26 gram, right? Given mass. Okay. Molar mass, what is the molar mass? We have to find out. Okay. Given mass by molar mass, this is 0.0 into 1000 by what is the volume? 200. Next, R value is 0.083, okay, and temperature is how much? Mentioned anywhere, 300 Kelvin, okay, and this is equal to 2.57 into 10 to the power of minus 3. Okay, so we have to find the molar mass here. Okay, let us do now. So what I can do, molar mass is equal to 1.26 into 1000 into 0.083 into 300, right, divided by 200 into 2.57 into 10 to the power of minus 3. So now let us do some approximation and we'll try to solve it. This and this I can cancel. Okay, so next this 2.57, right, is there, and okay, I can make it this one 10 to the power of 6 first of all, okay, and 1.26 I can cancel here, 2.63, okay, so I have 0.63, okay, this one and this one I have written already, then 0.08 I'll make it as 0.1, and I have here 2.57, okay, so somewhere 63 divided by 257. How can we make it somewhere which is very easy to divide? So let me try 63. Okay, let me divide this one division I can at least do here. So I'll get 630. So if I take 3 2s are 6, it will be more. 2 7s are 14, 2 5s are 10 plus 1 11, 2 2s are 4 plus 1 5. So 0.2 something I will get, right? 0.2, 1 second. So this is very easy direct calculation. So if you calculate this one, okay, so you will be getting around 61,038. Okay, so please do this calculation and let me know if you are getting this answer or not. Next, equimolar aqueous solution of NaCl and BaCl2 are prepared. If the freezing point of NaCl is -2 degrees Celsius, the freezing point of BaCl2 solution is expected to be. So equimolar is there. Okay, I can say that means equimolar as well. So I have this first one, delta TF, right, is equal to Kf into M. Okay, now for this is for example NaCl, and for BaCl2, delta TF is equal to I, here also I, into Kf into M. Now Kf into M, Kf into M will be same. Okay, so I value is what will decide, right? Here for NaCl it is 2 and then it will be, here it is 3, right? For 2 plus 1, 3. So the answer has to be -3 degrees Celsius. Okay, next, which of the following is a isotonic solution? So for isotonic solution you need to have the same concentration, right? So here I have total I value is 5 and I will get 0.005 here, right? And here I will get 0.3, right, 0.3. So it is not equal, so not isotonic. Here again 2 plus 1, 3, so I will get 0.003 here, and here I have 5, so that is 0.005. Again this is not equal. Next we have 0.01, so I will get 0.03 here, and I will get 2 plus 1, 3, 0.003. Okay, next we have 0.03 here, and if I have 2 here, then I will also get 0.03. So you can see here the C value is constant, so here it will be isotonic, option number D. Next, KH values are given and you have to arrange in the order of their solubility. So if you know if KH value will be more, then solubility will be less. Okay, solubility will be less. So we have, first we have to find the highest and lowest we can find and eliminate certain options. So argon value, okay, let me write down the values here. Argon I have, then carbon dioxide, then I have formaldehyde, and lastly I have methane. Okay, so this is 1, 2, 3 and 4. Now argon values are 40.3, this is 1.67, 1.83 into 10 to the power of -5, 0.413. Highest values of argon, so it will have the least solubility, so I can eliminate this option. Next, if I see the highest value, if I want to check, this is the least value, so it will have the highest solubility, that is 3. So again I will eliminate this option. So after 1, the next highest value is of carbon dioxide, so after that 2 will come, so that is option 1, 2, 4 and 3. Okay. Next, solution A contains acetone dissolved in chloroform, while solution B contains acetone dissolves in carbon disulfide. The type of deviation. So here if you see, acetone dissolved in chloroform will have more interactions and it will show a negative deviation. Okay, and here we have positive deviation because there is no interaction, so negative and positive. Next, a mixture of phenol and aniline shows the negative deviation from Raoult's law, and this is because of intermolecular hydrogen bonding. For an ideal binary liquid mixture, so whenever you mix something, okay, delta S is always greater than 0. Okay, so that has to be there. Delta X has to be there, and if it is an spontaneous process, delta G will be less than 0. Which of the following aqueous solutions has the highest freezing point? This is a bit tricky question. So if you see here, the depression will be 0.02, right? I value is 2. So 2 into 0.01, 0.02. Here it is 2 plus 1, 3. So 0.03. Here it is 0.1 and here it is 0.2. So now if you see that if the depression is maximum, then the freezing point will also be lowest. But the question is asking about the highest freezing point. So you have to find that solution where depression is minimum. Right? If depression is minimum, then the freezing point will be highest, and here I can find the depression is minimum, so option number C here. Okay. Okay, so students, these were the top 30 questions and I have picked up some previous year questions as well. So please practice similar questions and definitely you will be able to tackle this chapter. And do not forget, you have to at least practice 60 questions from this particular chapter because this is a very high weightage topic. So I hope if you have any doubt in any question, do comment down. I'll definitely address to it. So thank you for watching and see you soon in the next class.